Hi guys, so today we're going to do quadratic function applications with word problems. Hey, we've already done a bit of it before when we were talking about the graphs of quadratic functions, but this time we're going to add a little bit more. Okay, so here the key to quadratic word problems is understanding what you're given, okay, determining which variable you're being asked to find, and to get every term on one side before solving. Okay, so here's our first example. Okay, Jenna throws a ball in the air. The function h of t equals negative 16t squared plus 40t plus 5, where h is the height in feet and t represents the time in seconds, approximating Jenna's throw. Okay, so I always think of it kind of like a graph, right? What it means is that here it is. Right? This is our height of the ball, okay, and this is our time, right? So depending on the time, what height it would be at. Okay? So here, it asks us what is the, let's actually define some variables first. So here, it tells us that h is the height in feet, so that's important. H is height. Okay? And then here, t is the time in seconds. Okay, so first question A asks, what is the initial height of the ball? Okay, so this, if I define it, initial means the starting time, right? So when it says initial, I should think at the beginning, when time is 0, what is the height of the ball? Okay, so this is telling me initial t equals 0. Height here is asking me what would h have to be. Super simple. All I need to do, plug in 0 for t. Okay. So the height at 0 seconds, you might also recognize this as our y-intercept. Okay. So if time is 0, actually, instead of even solving for it, what we know is it's going to be our y-intercept. And so our initial height, even without solving it, is 5 feet. Okay, because this initial height is asking me for the y-intercept, which we learned in standard form is when c equals, is what c is. And we can see that if we had plugged it in, we would have gotten 5 anyways. Okay. So next here, when does the ball reach its maximum height? So when here is asking for the time. Okay, so it's asking you what the time is. And then that word maximum, you should obviously think vertex, right? So I want to know what is the x value of my vertex. Right? So we're going to do negative b over 2a. Remember that. So in this case, b is 40, so negative 40 over 2 times a, which is negative 16. This would be negative 40 over negative 32, which if I simplify it is 5/4. Right? Both of these are divisible by 8. Negative 40 divided by 8 is 5. Negative 32, 4. Okay. And as a decimal, this would be 1.25. Okay. So what does this mean? The ball reaches its maximum height in 1.25 seconds. And there you go. So it asks, what is the ball's maximum height? So now I want to know the y value, right? So I want to look at the h of the vertex. Or technically h here meaning the height, the y value of the vertex. Okay. So since I know it was reached at 1.25 seconds, I'm going to find the height at 1.25. I'm going to plug it in. So negative 16 times 1.25 squared plus 40 times 1.25 plus 5. Okay. So 1.25 squared is 1.5625. Okay, so dealt with exponents first. Then multiplication here. So negative 16 times 1.5625 is negative 25. 40 times 1.25 is 50, and then plus 5. Negative 25 plus 50 is 25, and then 25 plus 5 gives me 30. So what is the maximum height of the ball? The maximum height of the ball is 30 feet. Okay. Then the next question asks, does the ball ever reach 40 feet? No, it does not. Why? Because we just found the maximum height. The maximum height is 30. So no, it does not. Because the max height, at least with this throw, is 30 feet. Okay. Then scroll. So E asked me, what is the height of the ball after 5 seconds? Is this possible? Okay. So what this tells me then is that T equals 5. So all I'm going to do is take my T, which is 5, and plug it in. So I want to know what the height is at 5 seconds. So plugging in 5 for T, negative 16 times 5 squared, plus 40 times 5, plus 5. 5 squared is 25. Negative 16 times 25 is negative 400. 40 times 5 is 200. Negative 400 plus 200 is negative 200, and then plus 5. This gives me negative 195. So this is saying that the height of the ball would be negative 195 feet. Is this possible? No, this is not possible. And what that means, oh, I spelled this wrong. No, this is not possible. And what this means is that before 5 seconds passed, the ball had already touched the floor. Okay. Okay, so F here asks, when does the ball hit the ground? Okay, so what this is asking for, it is asking for those x-intercepts. It's asking for the zeros of the function, right? So when it's asking when does the ball hit the ground, right? So here it is. It wants to know when does it hit the ground. That's the x-intercepts. Those are the zeros of the function. We find that by plugging in 0 for y, and so that's exactly what I'm going to do. Okay, plugged in 0 for y. Okay, I'm not going to factor this or do all that. I'm just going to use the quadratic formula. Okay, so A is negative 16, B is 40, C equals 5. Okay, so let's solve this. Okay, so T for time, when does the ball hit the ground? T equals negative B, negative 40, plus or minus square root, B squared, 40 squared, minus 4 times A, which is negative 16, times C, which is 5, all over 2 times A. And this will be fun. Right? So let's simplify. Negative 40 plus or minus 40 squared. Okay, that's 1,600. Negative 4 times negative 16 times 5, that will give you a 320. And then 2 times negative 16 will give you a negative 32. Then I'm going to keep solving. So 1,600 plus 320 will give me a 1,920 all over negative 32. Okay, so for this, we're going to use the calculator now for it. Okay, so we have two answers. One of them is negative 40 plus square root of 1,920 all over negative 32. The other one is where it's negative 40 minus square root of 1,920 all over negative 32. Okay. When you type it into the calculator, this one will give you a negative 0.119, and this one gives you approximately 2.619. Okay. This is not a solution. Okay. And the reason why is because you can't have negative time. So as a result, only this is a solution, and what this means is that the ball hits the ground after 2.619 seconds. Cool. Next, G. When does the ball obtain a height of 20 feet? So here, H is 20. So I'm going to plug that in, right? So H here is really our Y value. So when does our height reach 20 feet? So I'm going to plug that in. So plug in 20 for H equals negative 16t squared plus 40t plus 5. Okay. I want it equal to 0, so I'm actually going to subtract 20 here. And when I subtract 20, 5 minus 20 will give me a negative 15. Okay. Now from here, I'm going to use the quadratic formula to solve. Okay. So t equals negative b, negative 40. Plus or minus square root b squared, so 40 squared minus 4 times a, which is negative 16, times c, now c is negative 15, all over 2 times a. Then keep simplifying. Okay, 40 squared we know is 1,600. Negative 4 times negative 16 times negative 15 will be negative 960. 2 times negative 16 is negative 32. Okay. Keep simplifying. Okay. Negative 40 plus or minus 1,600 minus 960. This will give me 640. Okay. Negative 32. Okay. Now here I'm going to split it up, and then I'm going to use a calculator. Okay. So the reason why I don't want you to use a calculator till the end here is I don't want you to round until the end. Okay. So here, oh, my bad. So one will be plus square root of 640 over negative 32. The other one will be minus the square root of 640 over negative 32. Okay. When you plug it into the calculator, this one will give you approximately 0.459. Okay. And then this one gives you approximately 2.041, right? Which makes sense, right? Since it's a parabola, there will be a point where both of them hit 20 feet, right? When it's going up and when it's going down. Okay. So what this means is the ball reaches a height, or reaches 20 feet at 0.459 and 2.041 seconds. All right. So the ball reaches this height twice. Once when it's going up, the other time when it's going down. Okay. So let's flip. Right, that was a long example. We're going to do one more just to get the hang of it. Okay, the height of a ball, golf ball in this case, can be modeled by this equation. So h of t equals negative 16t squared plus 76t, where h is the height in feet of the ball after t seconds. Okay, so here we want to know how long was the ball in the air, right? So it goes up, it comes down. how much time passed in between. Okay, so what this is asking for again is this is asking for the zeros of the function. Okay. And so zeros of the function, that's our x-intercept, so that means y would equal 0. Okay. And so this one, nice and easy, I'm going to solve by factoring. Okay. Negative 16 and 76, for those of you who didn't know, they're both divisible by 4. So I'm going to pull out that negative 4. Okay. And then since they both have t's, I can pull out t as well. Right. What I'm left with is 4t minus 19. Negative 16 divided by negative 4 is 4, so 4t, right, because I pulled out one of the t's. Then 76 divided by negative 4 is negative 19. Okay, so negative 4t equals 0, and 4t minus 19 equals 0. Divide by negative 4 on both sides here. T equals 0, which makes sense that in the beginning the golf ball was on the floor. And then this one here, add 19 divided by 4. So t equals 19 over 4. If I were to change it to a mixed number, that would be 4 3/4. If I changed it to a decimal, that 3/4 is a 0.75. Okay? And so what this means is that the ball was in the air for 4.75 seconds. Okay. Next question asks about maximum height. Okay. So here I want to find the y value of the vertex. In order to do that, I need to find the x value of the vertex. So here, y value of the vertex, so t equals negative b over 2a, so negative 76 over 2 times negative 16. 2 times negative 16 is negative 32. This equals 2.375. So that is the time at which it reached the maximum height. To find out the height, I would have to plug it in. So negative 16 times 2.375 squared plus 76 times 2.375. 2.375 squared is 5.640625. Okay. These multiplied together will give you a negative 90.25. 76 times 2.375 will give you a 180.5. And when you add these two, you end up with 90.25. And so what does this mean? The ball reaches its maximum height Oh, sorry. My bad. Let's delete that. The ball's maximum height, right? Because I'm not asking when it reaches it. I want to know what the actual height is. So the ball's maximum height is 90.25 feet. Right? And then the last question is, what is the height of the golf ball at 3 seconds? So here t equals 3. So let's plug it in. Negative 16 times 3 squared plus 76 times 3. 3 squared is 9. Negative 16 times 9 is negative 144. And then 76 times 3 is 228. Negative 144 plus 228 is 84. And so at 3 seconds, the golf ball's height, or the golf ball, is 84 feet in the air. Okay. That's it for today. Have a great rest of the day. Bye, guys.